Okay, so what I have is graphing y equals ax squared plus c. So remember, when we have a quadratic that's in that format, we know that the axis of symmetry is going to be at 0, at the line x equals 0. So let's go and take a look at it, and let's just kind of write down what our a and c are in this case, and that's going to be helpful so we can kind of see how do a and c affect our graph. So since a is the value that's being multiplied by our x squared, we can say a equals negative 1/4, and we could say c equals negative 2. All right. So what we're going to do to graph this, again, we just need to create an x and y table. And by graphing, by using a table, it's going to become very important again for us to always make sure we understand what the axis symmetry is, which in this case, again, we said the axis symmetry is at x equals 0, which I will prove and show to you when we graph it. But for right now, let's just go through the understanding that when you have an equation in the form of y equals ax squared plus c, that your axis symmetry is always going to be at the x value of 0. So that's going to be our starting point. Now, we can choose any point we like for x after x equals 0. We just want to choose 2 points to the left and 2 points to the right. However, to make the math kind of simple for this, for us, I'm probably not going to want to use values that are going to give me a lot of fractions. All right, point in case. If I use the number 1, so negative 1/4 times 1 squared minus 2. All right, so first of all, I'm going to have y equals 1 squared is 1. 1 times negative 1/4 is going to be negative 1/4 minus 2. Now, I'm sorry, negative 1/4. Now, there's nothing wrong with this. You guys should know how to convert fractions, and then convert this to negative 8. I'm sorry, negative 8 over 4, and then simply subtract to be able to find the fraction. However, when graphing fractions and finding fractions, a lot of times that's where a lot of mistakes are going to happen. So what I'm going to try to do is I'm going to try to choose values for my x that are not going to give me fractions. So therefore, what that means is I'm going to try to choose values that when I square a number, I can then divide that number by 4. All right? So rather than choosing 1 or 3 or 5, I'm going to choose some even numbers that are actually going to have that possible. So I'm going to choose negative 2 and negative 4. Now, if you want to use these values and then either do the math with fractions on your own, that's awesome. That's really good. Or if you want to use it and then use decimals with calculator, not recommended. However, you're still going to get the same answers. But without trying to do this with a calculator, a lot of times I see students making mistakes by trying to do fractions or converting to decimals. And also, it's not always sometimes accurate. So I'm going to try to use some numbers that are going to help me avoid some fractions. And I think mathematically, a lot of students like that as well. So I chose values. So usually, instead of doing negative 1 and negative 2, I chose negative 2 and negative 4. The reason being is because when I square those numbers, I can then multiply them by negative 1/4 or divide by 4, which is the same operation. So now what I'm going to do is, again, we need to find. So now I chose x values, x coordinates, 1, 2, 3, 4. 1, 2, 3, 4. Now what I need to do is find the other y coordinate for those exact values. So I have y equals negative 1/4 times negative 4 squared minus 2. Now notice how the c is kind of being added into this equation. It is going to affect our graph. So y equals negative 1/4. We're writing one thing, saying another. Negative 1/4 times negative 2 squared minus 2. Y equals negative 1/4 times 0 squared minus 2. Y equals negative 1/4 times 2 squared minus 2. And then y equals negative 1/4. Why do I keep on writing 1/2? I'm sorry about that. 1/4 times 4 squared minus 2. All right, so let's go and find out these values. So negative 4 squared is a positive 16. Positive 16 times negative 1/4 is going to be a negative 4. Negative 4 minus 2 is negative 6. Negative 2 squared is positive 4. Positive 4 times negative 1/4 is a negative 1. Negative 1 minus 2 is negative 3. Now, ladies and gentlemen, be very careful with make sure you're following the order of operations. Make sure we square our number first, then multiply by negative 1/4, then we subtract the negative 2. So 0 squared is 0. 0 times negative 1/4 is 0. 0 minus 2 is negative 2. Here we have 2 squared, which is 4. 4 times negative 1/4 is negative 1. Negative 1 minus 2 is negative 3. Again, remember, x equals 0 is our axis symmetry, so these values are going to be exactly the same. But let's just again show it. 4 squared is 16. 16 times negative 1/4 is negative 4. Negative 4 minus 2 is negative 6. All right, so now let's go and plot these. So I have negative 4, 1, 2, 3, 4, down negative 6. 1, 2, 3, 4, 5, 6. So it's going to be somewhere around there. Then I have negative 2, negative 3, 1, 2, 3. Then I have 0, negative 2. And then I go 2, negative 3. And then I go 3, negative 6. Whoa, 1, 2, 3, 4, 5, 6. Should be like down there. OK, so now what we're noticing, all right, as I kind of connect these points here, all right, this graph is going to keep on going down, right? The maximum point that we found is right here, which is our vertex. And that point occurs at 0, negative 2. All right, so that's very helpful. Let's also take a look at a couple other points we have here. Our line of symmetry, as I mentioned, you guys can see that this line of symmetry goes right down our parabola, right? So our line of symmetry, or our axis of symmetry, is going to be at x equals 0. Our x-intercepts, you notice that the graph does not cross the x-axis at all, does it? So we're not going to have any x-intercepts. And then we look at y-intercepts. And the graph crosses the y-intercepts at our vertex, which is at 0, negative 2. So just notice, ladies and gentlemen, when we have our equation in y equals ax squared plus c, what happened is our a, that made our graph now shift downward. So therefore, our vertex is now a maximum point. All right. We now have a line of symmetry is still at x equals 0. And we now have a c that now has actually shifted the graph down because it's negative, and actually shifted our whole graph down 2 units, which is kind of very interesting. So there you go, ladies and gentlemen. That is how you graph an equation using the table when it's in the form of y equals ax squared plus c. Thanks.